Now it's time to create the actions. As you can see, when the app is running, the actions that affects the item list include an action to add a new item and an action to delete an existing item. There doesn't seem to be any other action. Since they are item-related actions, we will create an item list action.dot file under the item list folder and define item-related actions in this file. The action to add a new item requires information about the item to be added. So create the class called addItemAction, declare a final variable item of string type, create a constructor, and override the toString. As mentioned earlier, if action is made into a class, the class itself can be used as a type. It's a feature of Dart. And if you need additional data to perform the action, you can pass the data through the argument of the constructor. An action to delete an existing item also needs information about the item to be deleted. So create the class called deleteItemAction, declare a final variable item of a string type. Create the constructor and override the toString. Next, it's time to create the search term related actions. An action that affects a search term may include an action that sets a new search term. There doesn't seem to be any other action. Since it is a search term related action, we will create a search term action.dot file under the search term folder and define search term related actions in this file. The action to search for items matching the search term requires information about the search term. So create the class called searchItemsAction, declare a final variable search term of a string type. Create a constructor and override the toString. Next, it's time to create the reducer. Reducer is a function that receives the current state and action object, decides how to update the state for each action, and returns a new state. Let's create a reducer in appReducer.out. The reducer function is a pure function that takes appState state and dynamic type action as arguments and returns appState. We will compute the new state for each action. If the action is addItemAction, then the item list state changes. So to make it easier to calculate, we'll store state.itemListState in the itemListState variable. Store.action.item, which is the item to be newly added, in the new item variable. Next, use the spread operator of list to add a new item to the existing item list and store it in the new items variable. Next, use the copy the function of item list state to generate the new item list state where the value of the item's argument is new items. Finally, a new appState instance is generated and returned. The value of the item list state argument is new item list state, and the value of the search term state argument is state.searchTermState, which is the existing search term state. If the action is deleteItemAction, then the item list state changes. So to make it easier to calculate, we'll store state.itemListState in the item list state variable. Next, while scanning item list state.items using the where function, create a new item list with items whose item is not the same as action.item and store it in the new items variable. Next, use the copy the function of item list state to generate the new item list state where the value of the item's argument is new items. Finally, a new appState instance is generated and returned. The value of the item list state argument is a new item list state, and the value of the search term state argument is state.searchTermState, which is the existing search term state. If the action is search items action, then a change occurs in search term state. So for ease of calculation, we'll store state.searchTermState in the search term state variable. Next, using the copy the function of search term state, create the new search term state whose search term argument value is action.searchTerm and store it in new search term state. Finally, a new appState instance is generated and returned. The value of the item list state argument is state.itemListState, which is the existing item list state, and the value of the search term state argument is new search term state. If there is no corresponding action, the existing state is returned. Now that we have created the state, action, and state, we'll inject into the widget tree after creating the store. Go to main.dart and import Redux package. We'll declare the late final store variable of fState type store, and then assign the store instance of fState type to the store within the main function. A reducer created in appReducer.dot in the Redux folder is provided for the reducer argument, and the fState.initialFactory constructor is assigned to the initial state. Next, wrap material app with store provider of fState type and give store as the value of store argument. Change the title of a material app to combine reducers, and let's set the value of debug show checked mode banner to false so that the debug banner is not displayed.